Now let's look at the introduction for the chemical oxygen demand experiment. Chemical oxygen demand experiment, or COD, is a common method used to measure the level of organic pollution in waste. It works by determining how much oxygen is needed to oxidize organic matter in CO2 and H2O. The test uses an acidic reagent to oxidize the sample, and the results are expressed in mg/L. Showing the mass of oxygen consumed per liter of solution, this helps classify the level of contamination. The main goal of the experiment is to assess the total chemical pollution in the different sample, as oxidation depends on factors like substance pH, the temperature, reaction time, and oxidizing agent strength.
Assalamualaikum, my name is Akmal Denibri Muhammad and I will be presenting about the procedure. There are three parts of today's procedure: sample preparation, digestion, and calibration. For sample preparation, firstly, the fresh reagent vial is picked and labeled for DI blank and sample. Micropipette set into 1 ml and attached with the tip. Then the sample container is rotated to make it homogeneous. 2 ml of water sample transferred to reagent vial while keeping vial at 45 degree and the cap of vial closed tightly and vial inverted several times. The same step was used when another tip of 1 ml. Secondly, digestion, where the vial is inserted to the COD reactor and the power is turned on. The temperature is set at 15 Celsius and time for 2 hours and the start button is pressed. After 2 hours, digestion is stopped and 20 minutes was spent to allow it for it to cool. And finally, the calibration. Spectrophotometer is turned on and is set to a specific factory method, and SCOD method is selected. Vial adapter added into the spectrophotometer. The blank vial is inserted into the adapter and then into the spectrophotometer. Zero button is pressed and the reading is recorded. The vial is then removed. And finally, the sample vial is inserted into the adapter, then into the spectrophotometer. The read button is pressed and the reading is recorded.
So my name is Amir Aswar bin Azrul, and now let's take a look at the analysis of the COD readings. The deionized water, as expected, recorded a COD value of 0 mg per liter. Our standard solution showed a value of 230 mg per liter. When we tested our samples, sample 1 had a COD of 165 mg per liter, while sample 2 had 81 mg per liter. So based on the result, sample 1 is considered polluted because its COD exceeds 100 mg per liter. Sample 2 is slightly polluted since its COD is above 50 mg per liter but still below 100. This means sample 1 is not suitable for daily use, while sample 2 may still be usable for non-conservative purpose like washing clothes or flushing toilets. So, higher COD values generally means the water has more organic pollutant. This leads to increased decomposition, which raises the demand for oxygen to break down this substance. So, to ensure our results are accurate, we must follow the procedure properly. So, all the samples should be mixed well before testing, especially diluted or wastewater samples. And finally, the spectrophotometer needs to be calibrated using a blank region before use. So that's all from me. Thank you.
For the conclusion part, based on the result, the COD reading for the standard solution is 230 mg/L, while sample 1 and sample 2 recorded the value as 165 mg/L and 81 mg/L, respectively. Therefore, it can be concluded that sample 1 is very polluted because COD is above 100 mg/L, while sample 2 is slightly polluted because range between 50 to 100 mg per L. This indicates that sample 1 are not suitable for daily use, but sample 2 there is exception to use in daily life, such as washing clothes and toilet flushing only.